Understanding variability helps us describe how spread out data are, not just what's typical. Two datasets can share the same center, but behave very differently in practice. We begin with the simplest measure of variability, the range. The range measures total spread using only two values. It is defined as the difference between the largest and smallest observations. This measure is very easy to compute and understand. While the range is simple, it has important limitations. It depends only on the minimum and maximum values. Because of this, it is extremely sensitive to outliers. A single extreme observation can dramatically inflate the range. Another limitation is that the range ignores how data are distributed in between. Two datasets can have the same range, but very different patterns of variability. To see this, let's look at a concrete example. Example 1 compares two datasets with identical minimums and maximums. Both have the same range, but their variability is very different. In dataset A, values are spread throughout the interval. In dataset B, most values cluster tightly around 5. The range fails to capture this difference. This motivates more robust measures of spread. To reduce the influence of extreme values, we turn to quartiles. Quartiles divide an ordered dataset into equal-sized portions. They help us focus on the center of the distribution rather than the tails. The first quartile, Q1, marks the value below which about 25% of observations fall. The second quartile, Q2, is the median. The third quartile, Q3, marks the value below which about 75% of observations fall. Together, quartiles describe how data are distributed across the middle of the dataset. The interquartile range, or IQR, measures the spread of the middle 50% of the data. It is defined as the difference between Q3 and Q1. Because it ignores the extremes, the IQR is resistant to outliers. The IQR is especially useful for skewed distributions. It pairs naturally with the median as a measure of center. Together, the median and IQR give a stable summary of typical behavior and spread. It is important to note that quartiles do not have a single universal definition. Different textbooks and software may compute them slightly differently. These differences are usually small and rarely affect interpretation. Still, it is good to be aware of them when comparing results. Example 2 looks at fuel efficiency measured in miles per gallon for 32 cars. Using JUMP, we find the first quartile as 15.275 and the third quartile as 22.8. Taking the difference leads to an IQR of 7.525. This IQR tells us how spread out the middle half of fuel efficiency values are. It focuses on the core of the distribution where most cars fall. Extreme low or high miles per gallon values do not distort this measure. In summary, the range gives a quick but crude measure of spread. The IQR provides a more reliable description of variability when outliers are present. As we move forward, the IQR will play a key role in box plots and outlier detection. Understanding variability is essential for interpreting data responsibly.